Was that a yes? Okay, cool. All right. Welcome everybody to a title only a Microsoft dev team would come up with, which is large-scale data warehousing and big data with SQL Server 2012 PDW. I had a different title for this session, but they took it away and gave us this one. So my name is Brian Mitchell. I'm a lead senior consultant with the Microsoft BI and Big Data Center of Expertise within Microsoft Consulting Services. What we're going to talk about today is SQL Server 2012 PDW. What I would like to know from you guys real quick to kind of do a level set is who here has been to a PDW session in the past? I see like 2 guys raise their hands. And that's partially what I was afraid of. This is going to be mostly a what's new to PDW session. I'm going to try to level set it a little bit by talking a little bit about some basics around PDW. If I'm going too fast, please let me know. I'll be happy to slow down and make sure that we cover some of the fundamentals. Also, one of the things you can do is after this session, if we've whetted your appetite about PDW, you can go to my blog and check it out. And there's a PDW page there which has links to previous sessions from previous TechEds and previous past sessions in which you can find more information about PDW V1 where we talked about it in detail. This is a little bit about me. I've spent a little over half my career working on SQL Server at Microsoft. I have a couple advanced certifications. I've worked with PDW since before we had our first customer. I was on site when we delivered our very first PDW to our first customer. So I've had some pretty good experience working with customers about the pros and cons of PDW and our travels from V1 to V2, and I'll be happy to talk about the details of that as we go on. Here's my Facebook Big Data Research. 68% of all Brians in the world are with an I. So my question to you is, why when I go to Starbucks, they always assume that it's with a Y? I don't understand, because they're always, that's with a Y? No, it's not. So hopefully I'm going to try to change the world by making everybody assume it's with an I by starting today. There's my blog information and my Twitter information. Just pimping out my Twitter to get more followers, I guess. So little level set about our data warehouse momentum. Who here was at the Big Data Foundational session this morning? So about half the crowd or so. That was a really good session on big data, PDW, some of the direction we're going with trying to integrate all those forces together. It's really an exciting time to be working in data warehousing and BI right now at Microsoft. The commitment the product group's making to BI and to data warehousing is unprecedented at Microsoft. And here's just an example of some of the customers that are PDW customers just within the last year. It's just a subset of the customers and the kind of momentum that we have with PDW and SQL Server data warehousing. Gartner has recognized Microsoft as a leader in data warehousing and business intelligence. And so that's always a good thing to know that we're on the right track with both of those things. Here's an example of an example customer. One of those many customers that you saw just a minute ago, and the kind of performance improvements that they saw when they started moving to PDW V1 even, which is 100 times improvements in queries that took 20 minutes now only taking 20 seconds, queries in which before they were doing things off aggregations and market baskets, they are now doing item level queries. PDW does give you the ability to really drastically change how you look at your data warehouse and what kind of queries you can actually expose to your end users in their BI environments. And we'll talk in detail about that today. So you guys have probably seen some slide like this in the past, which is data is growing. We talked about that at the foundational session this morning. And that's just a simple fact that data is growing exponentially, not linearly. So we are collecting more sources of data, and the data that we do have is growing. And customers are also wanting to keep longer histories of data in their data warehouse, while at the same time expecting you to provide more real-time-ish access to that data. So that's just a fact. And then consumerization of IT, we talk about it a lot here at Microsoft, and we talk about it a lot with our customers. From a big data or PDW standpoint, the way I see it is consumerization of IT means that our users are less likely to be patient for data to come back, because Google and Bing have made it seem to them that you can write a query against the whole corpus of the internet and get an instantaneous response, right? So they expect that from our applications. And so an appliance like PDW that can scale to your needs can provide that kind of response times for your end users and speed up the kind of queries that you're looking for. And we'll talk in detail about some of the changes we made in 2012 to make that occur. So capitalizing on all these changes of big data means that we need to understand what it is. For years, we've mostly worked in this space as data guys, right? We've mostly worked in the ERP and CRM space, dealing with things like inventory and sales and those point of sales and those kind of things. Over the last 5 to 10 years, we've been dealing more with the Web 2.0 world of adding on web logs and recommendations and e-commerce into our environments. And then as we start grappling with this big data stuff, how do we handle bringing log files into our environment? How do we deal with social sentiment, clickstream data, or raw text images into our environment? So dealing with big data is going to be a big deal. Whether or not you're doing it today yet, or it'll be something coming in your near future, how do we handle that, and how do we use something like PDW as an appliance to make sure that it is built so that it can handle this kind of data? We'll talk about that today. So generally speaking, to handle that, our options are fairly limited. We can keep our legacy investments. We can keep our S&P environments and continue to scale those up. Microsoft is making a big investment in making sure that you can scale as much as possible. Some of the things that you heard this morning about Hackathon or column store indexes makes it so that we can get more out of the S&P environments that we have today, but that you're still dealing with constantly trying to change your applications to use these new tools as they come along. You can buy a new Tier 1 hardware appliance from some of our competitors. Generally speaking, I can tell you that those are going to be significantly more expensive than PDW is. But we'll talk about the details of that later. You can acquire a big data solution, so you can install Hadoop on a Linux environment and kind of scale out that way. That's certainly always an option to deal with some of those big data problems. It's going to require some training on your user's part. It's also going to require some new infrastructure. And then, of course, you can acquire business intelligence and deal with the solution complexity. Is all that stuff integrated back into your big data solution you just created or your Tier 1 appliance? So having an integrated business intelligence with your data warehouse is always a useful thing to have. And we'll talk in detail about how our BI stack at Microsoft integrates seamlessly with PDW. So what we have is PDW. We have the ability to build for big data. And we'll talk in detail about Polybase and how you can store your structured and unstructured data inside or outside of PDW, but query it using some simple syntax. We'll talk about next generation performance at scale, which is Xvelocity and clustered column store indexes within PDW, updatable clustered column store indexes in PDW, SQL Server 2012. And then finally, engineer for optimal values. So we were able to use the power of Windows Server 2012 and direct attached storage to get rid of some very expensive third-party SANs and other things that we had in previous versions of PDW to make it so that it is much more optimal value for our customers. That's the introduction. What is PDW? So first of all, just to make it clear, and I put this slide in here because sometimes when I have crowds like this that haven't been to a PDW session before, we need to understand that PDW is an appliance. You can't download it off the internet and install it on your own machines. It's not available in Azure. It is an appliance that you buy from our hardware partners, and we'll talk about who those partners are in a little bit and how you go about deciding on configurations. So it's built in the factory. What that means is that when you work with Microsoft and our partners, they actually build PDW in the factory so that they build it right in the rack, they install the software, and then they box it up in a pallet and they send it to you. So when it arrives on your doorstep of your data center, they literally can wheel it in, plug it in, and get it going, and you can be loading data within a day or two. It is that simple. So being built in the factory is a significant, important thing when it comes to installing your data warehouse environment. Because if you think about it, you think about how long it takes for you to build your own data warehouse environment today. It takes months usually for you to sit there and think about what you're going to purchase, how you're going to configure the software, arguing over SAN and LUNs and all that kind of information, and getting it all installed in your environment. And then by the time you do that, you're months into your project, and you really have no value. With something that is built in the factory as an appliance and delivered to you, you can be using it literally have your data loaded pretty quickly. It's optimized for data warehouse workloads only. So that's pretty important. This is not an OLTP appliance. This is an appliance that is built to drive your data warehousing environment and usually some sort of BI environment on top of the data warehouse. And it is built with Windows Server 2012 and SQL Server 2012. Those are the foundations for PDW. So here's kind of the agenda and the details of what we're going to talk about. We're going to talk about a little bit about the architecture, just software architecture really quickly. And then we'll talk about our appliance configurations and then the new features of SQL Server 2012 PDW. Our memory optimized column store index, management simplicity, polybase, and then we'll talk a little bit about Power View integration and finally some T-SQL parity, and I'll take questions. So as I'm going through this, if you guys have any questions, I'm fine with interactivity. I don't mind at all. In fact, I have a SQL Server 2012 USB stick for the best question of the day, which I'll give away at the end of the session. If there's too many questions, we'll just slow it down and I'll ask you, let's just hold them off to the end, but I'm fine with taking questions. So let's go ahead and get started. Basically, if you wanted to know one thing to kind of level set what you need to know about PDW when it comes to how is it different than S&P SQL Server, I would say that you need to understand the difference between replicated tables and distributed tables. And if you understand that, then that really helps. So remember, PDW is an appliance. It is multiple SQL servers within an appliance. And one of the things we do is we shard your data across nodes, essentially. Within the PDW environment, we use the term distribute your data. So one of the things we have is choices. You can either replicate your data or you can distribute your data. Replicate your data has nothing to do with SQL Server replication. All it means is that when you create a table that is replicated, which is the default structure. And what that means is that a full copy of that table exists within each PDW node. So we make copies of it and we put it on each one of the SQL servers. The reason we do that is simply for performance as we join tables together. So generally speaking, your replicated tables are going to be your smaller tables, and they're generally speaking going to be your dimensional tables if you're doing like a Kimball data warehouse kind of environment. So think tables 5 gigs and less, which is a majority of your tables, and you just replicate them out, and that really helps with the performance. Distributed tables, on the other hand, are tables that we hash based on a column that you give PDW. And what we do then is basically every row that gets inserted into PDW is hashed on that column, and then is then stored on one node and one node only based on that hash. And that's really an important thing. So what we do is we spread your data across. If you have a one data rack appliance with 8 nodes in it, then that row is only going to live on one of those 8 nodes. And so that way when you query data, that's how we're able to get the massively parallel performance out of PDW by only having to deal with subsets of data on each one of the SQL servers as we bring it back together and then give it back to the end user. So visually a little bit, what that looks like is for your dimensional tables, we'll take a dimensional table and we'll replicate it out, and it gets a copy of that dimensional table on each node within the appliance. And this is just a little half rack appliance within PDW of 4 nodes, or I guess that's 5 nodes. On the other hand, your larger tables, generally speaking, your fact tables or your really large dimensions, if you're a large company, then maybe customer dimension might be, you might have millions of customers. What we'll do is we'll take that data and we'll actually shard it out so that each one of those rows actually resides on only one compute node within the appliance. And in fact, the little detail underneath the hood there is on each one of those compute nodes, we have 8 different distributions. So in this particular, or a typical one data rack appliance with 8 compute nodes, we actually have 64 distributions across it. Each row goes into one of those 64 distributions. And so when you do a query against that table, select star against sales fact, what it's going to do is send 64 queries back to those back distributions, and each one of those queries is going to run, and then we're going to aggregate that data back together before we send it back to the end user. So at a high level, that's kind of what those do. A replicated table, it's just the same way that you do it today. You're just creating a table just like as you do today in SQL Server. A distributed table, on the other hand, all you do is you have the with statement at the end where you say your distribution equals your hash, and you pick the column that you want to hash on. And we have lots of presentations that you can find from past and TechEd previously when we talk more details about this and best practices and all that. We really don't have time for that today because we really want to talk about what's new with SQL Server PDW and what's really exciting about 2012. So let's start with appliance configurations. Our 2 partners are HP and Dell. And their configurations are slightly different, and we'll kind of walk through what those look like. So first of all, let's talk about the difference between a V1 and V2. So a V1, basically a one data rack appliance, was really two racks. It had a control rack and a compute rack, and there was lots of hardware in it. There was lots of SANs involved in it. So if you had one data rack appliance, you had 11 physical servers in your compute rack. You had 10 SANs. There was lots of interconnects between the two. There were SANs on the control rack for both the control node and the backup nodes. So there was a lot of hardware involved there. And while it was a dramatic improvement over previous versions, well, we didn't have anything like this in the past. This was really exciting and really good. PDW V2 takes us all to a new level. So one of the things we've done is we were able to shrink down our footprint from 2 racks down to 1 rack. And then after doing that, we were able to give each node more memory, more CPU, and actually with the 1 rack as opposed to 2 rack, we actually have more space for data. So what that does is, by getting it down to 1 rack, our pure hardware costs are much less expensive than they were before. And our price per terabyte is much lower than it was before. And our performance goes up significantly. And mostly what we'll talk about over the next hour or so is where we're getting those performance gains. But it's pretty exciting to see the differences in, faster improvements in performance and much less cost to the end user. All right, so how do we do that? So some of the key design changes we made in PDW are, first of all, we went to one standard node type, and that node type has 256 gigs of memory. So when you buy a 1 data rack appliance with 8 nodes in it, each one of those nodes has 256 gigs of memory because we're going to drive pretty hard through that memory. Also, we updated the newest InfiniBand, so we went from DDR to FDR, which allows us a much faster performance of interconnects between the nodes in the appliance as we push data throughout the appliance and back to the end user. And then really importantly, we moved from SANs to JBODs. So using Windows Server 2012 technology to just manage the disks and get rid of those expensive third-party SANs was a significant deal for us. It really reduces costs, allows us to use Windows Server 2012 to manage stuff in the same way that we do in other environments. And then finally, we also removed what we called the backup and the landing zone, which were previously integrated into PDW, and now they're part reference architectures. Reasons for that were customers had wildly varying needs for both backup and landing zone. And while we provided a landing zone that had basically 8 terabytes of space in it, there were customers that needed more space. And we provided a landing zone that had, I think it was 8 CPUs in it. That wasn't enough for some customers, depending on what they were doing. Some customers had multiple loads that they wanted to do at any given time, and they would prefer to have multiple landing zones. So what it really came down to is we found out that it was actually better to just pull those out of the appliance and provide reference architectures. And that gives the customers more agility, possibly even to just leverage SSIS environments that you already have, for example, without having to pay for a landing zone built into the appliance. And then we have the scale unit concept, which is basically the ability to add either 2 or 3 compute nodes and the related storage at any given time. So we start off with a quarter rack, which essentially looks like this, where you just have 4 hosts, and 2 of them are compute nodes down there at the bottom, host 2 and 3, attached to a JBOD. That's essentially where you can start, and then you can scale up from there, and we'll go into detail about what that looks like for both of our vendors. So an HP configuration basically can scale from 2 to 56 compute nodes. And this is kind of that scale for everybody kind of mentality that we have. When we start talking about 2 compute nodes, we're not talking about a large appliance. We're actually talking about something that most everyone that has a decent-sized data warehouse that's in the terabyte range at all could probably leverage at some point. So what that looks like is this, is that at the top what we have is we have our interconnects for InfiniBand and Ethernet, and we have a control node and a failover node. And then we add a scale unit down at the bottom. We start off with our base unit, and in HP, that's going to be 2 servers. They have 16 cores each for a total of 32, and it has a total of 15 terabytes of raw space, which approximates out to about 75 terabytes of user data capacity when you start talking about compression. So at a minimum, that is a really exciting entry point into massively parallel worlds. And what you can do from there is, as your needs grow over time, you can add additional scale units to the point where we can have, in an HP environment, up to 4 scale units, which is 8 compute nodes within the appliance. That gives you 60 terabytes of raw space within the appliance. And that's for a 1 data rack. So we can go up from 1 to 7 data racks for that appliance. Now, what's different about PDW that is compared to SMP is when you start at this scale unit down here of a scale unit of 1 and you need to grow, you add that second scale unit and work with Microsoft, and we can redistribute your data across all that entire appliance. So that's different than an SMP environment where you have a box and you run out of space and you need to decide to grow more space. You buy a new box, and then you have to go through this expensive and very time-consuming migration process. The difference that's really exciting for MPP and for PDW is you just scale as needed. So if you scale, let's say you start at a half rack like we see up there, you need to go to a full rack. You come in, you add 2 more scale units, and you redistribute your data, and you're now leveraging the entire appliance without having to do any lift and shift like you could have to with an SMP environment. There may be some small downtime, but that's much different than a big lift and shift in a normal SMP world of moving from one box to another. And then finally, we have a little extra space for ETL servers and backup servers for customers to add into the appliance and hook up to InfiniBand so that they can load the appliance as necessary. So that's 1 data rack. You can then slowly add quarters again to 2.5 racks, and then you can add another half, and you can get to 2 racks, add a third rack, and on all the way up to 7 racks. So that's the HP configuration. Dell's slightly different. Dell comes with 3 compute nodes and 2 JBODs in a base unit. And the way that and that gives you basically about 22.6 terabytes of raw space, 79 terabytes of user data in that environment. And so basically what they do is we scale in thirds in a Dell environment so that you can have up to 9 compute nodes. You get a little bit more space in that particular appliance configuration. And then, of course, they still have space for the customer use. And then, of course, you can go up to 54 compute nodes, up to 6 racks, and on and on. So they're fairly comparable, really performance-wise, between the two. Whether or not it's the 9 or the 8, it's really fairly negligible. It's really just up to you on what your particular vendor of choice is. So the supported growth topologies kind of look like this. We'll be able to grow from a quarter rack up to 7 racks for HP, or from what we call a quarter rack or a 2/3 rack, all the way up to 6 racks in Dell. And what you can see there is you can basically start off with 15 terabytes of raw space and basically grow it up to 422 terabytes of raw space, which gives you about, for that particular environment, about 1.4 petabytes of space. If you use the 3 terabyte disk, you could probably get up to about 6 terabytes or petabytes of space as needed. So you can grow to basically any size. And I'm sure as time goes on, we'll continue to grow the amount of space that we can handle as PDW continues to mature. So how do we do this? So one of the things that we do, yes, sir.
You said you can keep adding the nodes as the data grows. What about at some point you want to decide that the data is not going out there with the node, so you will just take out one rack from 5 to 4. Can you do that if the data is reduced and it's not utilized fully in one rack?
So the question is, if I have 5 racks and I want to go down to 4, can I take out one of those racks? The answer is yes, you could. Is it going to? You would have to work with Microsoft to do that. We would have to reconfigure it to be at 4 racks. You would basically have to take a backup of your data and then restore it. It wouldn't be a trivial thing. It's not. Growing is one thing that we have planned to shrink like that. And then what would you do with your 5th rack? Just what are you going to do with those servers? So yeah, I mean, there's a lot of questions there. It can be done, but it's not a trivial thing like growing is what I would say. So let's talk about how we do some of this agility through virtualization. And this is pretty exciting. So PDW v1 did not have virtualization in it. We just did everything right on the bare metal as you probably normally do in your environments. But what we found over time as you moved to Windows Server 2012 and SQL Server 2012 is virtualization. The performance hit that you get is negligible, if any. And so one of the things that we can do from an agility standpoint is to use virtualization in that. So instead of using failover clustering like we did in V1, we're now using virtualization to manage our high availability in PDW. And what that allows us several pieces of agility that are actually pretty nice. So what you see there is you have your storage spaces and within the JBODs, and those compute nodes are connected to the JBODs like that. But what happens if we have a failure of host 2 is basically that compute node is moved over to our spare node, which is called host 1 in the appliance. And he can still have access to the JBOD as long as compute node 2 is up and running and has access to the disk. So we are able to use InfiniBand to connect back through the disk. So no matter where that virtual machine lies within the appliance, and it can fail over from one rack to another rack, he still has access to his disks as long as the other server's up. In the case of a failover like that, what we'll do is you can work with Microsoft support, and they'll work with you to get host 2 back up and running, and then fail compute node 1 over. So essentially, there's just one cluster across the whole appliance, and it's pretty exciting that the virtualization is used that way. So LUNs and file groups and disk layout. So what we have basically within one of those JBODs is we have 70 disks. And what we're able to do is we create 33 mirrored drives so that we can lay out our data. So one of the things I told you earlier is that in any particular compute node, you have 8 distributions of data. And each one of those distributions actually physically on the back end is just a table. So you create a distributed table for fax sales, and that has eight compute nodes in it. You're actually creating 64 physical tables on the back end, 8 per compute node within your rack. And so in PDW v1, that essentially leveled out to each distribution went to a file group, which went to a file that was on a mirrored RAID 1 array. And one of the things that we found out was that was great as long as we didn't have a lot of data movement, we didn't have a lot of activity. So one of the things we did with V2 is we essentially doubled the number of disks that we have available to each one of those distributions. And so now when you create a distributed table, it creates 8 tables on each compute node. Each one of those 8 tables is associated with a file group, and each one of those file groups has 2 files behind it, both on they're separate RAID 1 arrays. So what we've done is we've significantly improved the I/O behind the system so that we can handle pretty much every workload you can imagine when it comes to pushing data through the appliance. So those distributions are now split into 2 files. Also, what we've done to really improve I/O is to move tempdb off some local disks in V1 and move them out to the JBOD and spread it across basically what is 33 or 32 RAID 1 arrays. So tempdb is no longer constrained to a certain size. It can grow through your JBODs, and it also has a significant amount of I/O behind it. This is really important because PDW uses tempdb extensively as we do movements of data and aggregation of data internally before we present it to the end user. All right, so let's talk about actually what is probably the most exciting introduction into PDW v2, which is the memory optimized column store index and xVelocity. And that's supposed to turn. All right, so we've had xVelocity around for a while. It started off in Excel and it started off in Power Pivot. As it grew from Power Pivot to Analysis Services Tabular Mode and SQL Server 2012, one of the key limitations to tabular mode and non-clustered column store indexes is that you cannot update them, right? And this has become, kind of, I would love to use it, but it becomes kind of a pain to use. So when we started talking about wanting to do column store indexing within PDW, one of the things that was just an absolute must was that it had to be an updatable column store, something that is updatable that we can use. So, and the product group came back and did us one even better. They gave us an updatable clustered column store within PDW, and it actually made it into PDW before it made it into the SQL Server Box product. This morning they talked about it a little bit about SQL Server 2014 will have clustered column stores in it. So what that means for us is that for PDW now, the default, it's not the default, but from a services perspective, when we think about how we implement tables within PDW for 2012, the thing that we're going to go to first is a clustered column store index for our data. What that means is we're no longer storing it in a row store at all. We're storing our data. There isn't a copy of the data between the row store and your non-clustered index. You're just storing everything in column store indexing. And what that does is it gives you a significant reduction in the amount of space used. And if you significantly reduce the amount of space on disk, then that is a lot less information that you have to pull through in I/O, and a lot less information you have to pull through CPU, and a lot less information you have to store in memory. So it significantly improves performance all over the appliance, such that you can deal with much larger data sets and get much faster query returns. And when we talk about 10 to 100 times in performance improvement, that's over PDW v1, which already gave you significant performance improvements over SMP. And when we talk about 7 times data compression, that's what we're expecting to see out of data compression when you go to a clustered column store index. So what does that look like? So how do we deal with the updatable part? And that's kind of important, and we'll talk about that. So basically, a clustered column store index is comprised of 2 parts. We have a column store index, and then basically we have a row store. And that row store is what you are used to today, which is just a typical row store table. And basically, that to the end user, you don't see any of that complexity. If you create a table with a clustered column store index, within PDW, this is how we go in and implement it, by providing a row store that basically, as you do inserts into the table, those inserts go into the Delta row store first. As we compress the data in the column store index, basically we compress it into million row segments, approximately, just like we do with non-clustered column store indexes. And the idea behind it is that the minimum I/O between disk and memory is those segments. And finally, also, the execution of batch mode is pretty important too. So batch mode has been enhanced from SQL Server 2012 to PDW. And we'll talk about what those enhancements are, so that you're more likely to get batch mode if you're using your column store indexes. So typically, batches are about 1,000 rows at a time. And basically what that means is if you're able to leverage batch mode, that means that instead of going a row at a time through the CPUs, we're doing 1,000 rows at a time through the CPUs. And that essentially just reduces the amount of work CPUs have to do, which significantly can improve performance. So you can see down there an example of a couple different things. Fact internet sales row, ran in about 6.7 seconds. You do the exact same data with a column store, and if you get batch mode like that, you'll see it ran in less than half a second. Same data, same structures, just the difference between row store and batch mode. You can also see there on the estimated operator cost where it goes from 41.8 down to 0.6. It's a significant game changer. And really, there's very little you have to do other than create your column store indexes or your clustered column store indexes and just leverage them. And that's what's nice, is whenever you're able to get significant improvements in performance without having to do a lot of juggling on the back end. Key here before I go on, though, batch mode's processing is only available for some operators. So hash joins and aggregates are supported within PDW. Right now, merge joins, nested loop, and stream aggregates are not supported. But this really isn't a big deal, because whenever you're doing PDW queries and you're joining a fact table that has millions or billions of rows to multiple dimension tables that have hundreds of thousands or millions of rows, you're almost always wanting to do hash joins anyway. That's essentially what we're looking for in PDW, is we want to scan the data, put it into memory, hash join it together, and then give you an output of a result set. Generally speaking, whenever you see large data warehouses and you're doing a Kimball data warehouse and you're doing nested loop joins through large fact tables, you're doing it wrong. So the supported modes are actually the modes that we're generally speaking looking for whenever people are using PDW or any data warehousing tool for that matter. Yes, Jeff?
Can you talk a little bit about how you handle the updates? You said it was updatable. How was that handled?
I would be happy to. I'll go to the next slide. So how DML is supported. So this is how we go about supporting updates. Inserts are inserted into the Delta row first. And so inserts go in there, and it's just a page compressed heap. And once you get enough inserts into the Delta row store so that it can be compressed, it will go ahead and do that through what we call a tuple mover. So basically, once you get about 1 million rows in each one of those distributions, Delta row stores, it will then do a tuple mover and actually move it into the column store. Deletes, on the other hand, if you want to delete data from the column store, it's essentially just a logical delete. We essentially mark it for delete, and then we'll actually get rid of that row whenever you do your next reorganize of your data. Updates, Jeff, are basically an old journaling technique of doing inserts and deletes. So we'll do an insert into the Delta row store, and we'll mark the old row for delete as necessary. And so what that allows us to do is it allows us to have this column store index. It's clustered column store index. It allows us to insert rows into it and then move those rows into column store once we have enough of them in the Delta row store. Essentially, the Delta row store, because it's just 1 million rows or less at any given time, even though it's not part of the column store index yet, there's going to be very little performance impact by having some rows in there at any given time. And we would expect you to generally have rows in there, especially if you're trying to do updates throughout the day. On the other hand, if you're doing large batch inserts at night, ideally, I would like to, you probably would like to see you do the large batch insert, do a reorganize of your cluster column store index, and that way you compress everything, and then that way everything's in your column store throughout the day. But if you need to do trickle-in updates through the day, you can certainly do that in PDW now with a cluster column store index without any problems. So we have some new DMVs available to us that allow us to kind of see in the back end. One of the reasons why you'll see a lot of screenshots of things like this is it's really hard to get a PDW appliance to do demos. There's only so many PDWs within Microsoft, and all of those are usually being used to sell to customers. We're usually doing some sort of POC or something like that on those appliances. So little guys like me that are out in the field, it's really hard. So I take a lot of screenshots and try to show you guys that way because that's the best I can do. So here's an example of some additional DMVs available. And so let's, at first, basically you just have a table that has cluster column store index on it. It's been compressed. And then we insert a row into it. And once we insert that row, you can see that first row up there shows us that we now have an open state description. What that means is I now have a Delta row store, so that I've added a row into the Delta row store for that particular table. And then after the rebuild, you can see that my total rows for one of those indexes goes up by 1, and the Delta row store disappears. So that's essentially how we handle that through PDW as we add data to it. In a little more detail, compressed basically shows whether or not we have a row group that is in column store format. Open shows a Delta store that's accepting new rows. And closed represents a Delta store ready for reorganize. And you can kind of walk through this example in the slide deck that you can get online to get some more details about how we go about working that. But essentially, at the end of the day, what you'll see is if you're inserting more than 100,000 rows, we'll compress it automatically. If it's less than that, then it'll be put into the Delta store, and then you'll have to manage that with the reorganizer or wait for more rows to get added. It's also partition friendly, and I'm not going to spend too much time on this, but the idea is that we can handle partitioning just fine with clustered column store indexes also. And you can read this in more detail in the deck later on. So the syntax is similar to PDW v1. Basically, you can create a table, and you give it your distribution column, and then you also tell it you want it to be a clustered column store index. That's it. What that means is your entire data set is stored in a clustered column store, all of it. So there is no more row store. There is no more additional indexes you need to add. It's just all going to be stored in column store format and be accessed that way. If you want to know more about what column store indexing does for you from a performance standpoint, I do have a session on Thursday on column store indexing period for SQL Server 2012/2014. We'll talk about clustered column stores in there for 2014, and we'll go into details about how column stores are actually managed pretty well there. So you can also do a create table with a create index statement or a CTAS. CTAS is a special statement within PDW that basically create table as a select. So you can create a brand new table as a select from another table or another set of tables. And you can also create your cluster column store index within that period of time also. And then CTAS with the column store and basically what that looks like, and you can go into the details there. And additional DMVs with additional metadata so we can look at the column stores as necessary. Lots of detail there. Basically, at the end of the day, what you want to know is that you'll only now have only a single index on your table. There's no need for a clustered index plus a non-clustered column store. There's no reason for a clustered column store plus a non-clustered row store. In fact, non-clustered column store indexes are not supported in PDW v2. You just have the clustered column store indexes. And then also some more details down there. Basically, every PDW data type can be included in the column store indexes, so that's a big deal. That we actually added data types from SQL Server 2012. And batch mode processing, you're much more likely to get than you would have in 2012 also. So this is really exciting for us, all the changes here, to make sure that you get that performance as needed. And finally, some details there around that. So what we're going to talk about next is management simplicity. And the idea here is that we've added some built-in resource classes, essentially leveraging on the back end resource governor to provide DBAs the ability to manage their environment a little bit better. What we found with PDW v1 was that oftentimes there were certain groups of users that needed more resources to complete their queries depending on the size of their queries or the importance of the user. Also, ETL loads sometimes needed more resources allocated to them so that they could perform as the customer wanted. And what I mean by that is sometimes in PDW v1, the customer would have an ETL load that would run in an hour one day and run in 2 hours the next day. And it was mostly because of competition for resources. So what we were able to do was we were able to create new resource management classes, which basically allow DBAs to basically hand out concurrency slots so that users can get more resources across the appliance. And essentially, the default behavior is what we had in PDW v1, which is that you got one concurrency slot, and that's what you got no matter who you were, no matter what process you were running. What we provide now within PDW is you have a total of 32 concurrency slots. If you want to, you can give somebody, either at the user level or at a load level, like if you're doing ETL, medium, large, or extra large resource classes. And in fact, you can see if you give somebody an extra large resource class, you're going to use 21 of those 32 slots. But there's appropriate, perfectly good reasons why you may do that. And one of those is those ETL processes that I was talking about. If you have an ETL process that runs at night at 2 o'clock in the morning, and you want to give it, and nothing else is going on in the system, and you want to give it the most resources possible so that it will get done as quickly as possible and as efficiently as possible, you can give it an extra large resource class, which means every single connection is going to get 4.2 gigabytes of memory on each distribution across the appliance. And that's, or I'm sorry, 8.4 gigabytes of memory across the appliance for each distribution. And that's a big deal. So that's when you start talking about 64 distributions times 8.4, you start seeing the kind of memory that just that one resource that might be doing some ETL might be able to get. You may have other users that have very specific queries, maybe coming from analysis services, maybe in tabular mode, for example, that you want to give medium or large resource classes to so that they can get back in a very good expected time. This is essentially just the ability for DBAs to be able to manage the system a little bit better. We have some DMVs that will allow you to kind of see in the back end a little bit so you can kind of manage that, see who's coming into the system, what queries they have, what their resource class is. So the DBAs can certainly manage that pretty well. And one of the things that's kind of important to know about is resource classes and column store indexing. One of the things that we have found by doing some testing is the larger your resource class, the larger your segments within your column store indexes are going to be. So this is an example at the top one where you can see where they just had a default resource class, and it was actually compressing rows pretty quickly as on a system that was fairly competitive and had lots of things going on. As it runs out of memory, it will go ahead and compress the rows. You can see down below when you add somebody with an extra large resource class, the exact same load, just had one row group and one delta, and was able to load all the data into that, so it was able to compress it. The more compression you have, the less segments you have, then the better your performance is going to be. Now, the top one, what you can always do is you can always do a rebuild of the index, and it's going to compress your segments down to less segments. But it was just an interesting facet to kind of understand how your resource classes, especially when you're talking about ELT loads at night, can affect how your data gets stored on disk. So this morning during the during the keynote and during the, they talked a little bit about Polybase and how important it was. And in fact, I heard Sean Bice talk about how it was, if you were going to take one thing away from the PDW v2 or SQL Server 2012 PDW, it was go read a little bit about external tables and Polybase. And we will talk about that. I actually think the column store indexing is just as important, if not more important, from how great PDW is going to work for the average end user who wants to just store their data warehouse workload on PDW. For people as they want to get that agility and be ready for big data, this is a big deal. So when we talk about Polybase and everything, what we're essentially doing is being able to say that you can use Hadoop or HDInsight in an environment, but not necessarily have to retrain your users how to do Hive jobs and Pig jobs. If you can store, you can use Hadoop and HDInsight to store a lot of your data as it's coming into your environment, but still leverage all the skills that you have today by just creating external tables over it from something like PDW. So what you can get is the ability to, within PDW, query your relational data and your non-relational data that's sitting out in Hadoop in one familiar interface, and that's by creating the external tables over them. And that's absolutely true. It also provides some agility when we start talking about housing your data long-term, and also from backup and recovery, and we'll talk a little bit about that. So basically the idea is external tables are the ability to basically do SQL queries across your data stored in HDFS. And the idea is that we have this new HDFS bridge that's within PDW that allows us to communicate to Hadoop from PDW so that we can parallel import into PDW. And that's kind of the key difference. There's lots of tools that make it available so that you can move data from from something like Hadoop to something like SQL Server, or something from like Hadoop to PDW. You can use integration services to move data from Hadoop to SQL Server. You can use Scoop to move data from Hadoop to SQL Server. You can use integration services and Scoop to move data from Hadoop to PDW, but it's single-threaded. So you're moving data from one node, or all these nodes, these maybe dozens of nodes or hundreds of nodes in Hadoop, single-threading it out and moving it to SQL Server, and then loading it into SQL Server. The difference is when you start talking about Polybase, what we're talking about is we're talking about multi-node to multi-node communication. And that's what's really exciting about Polybase. And that's how we're able to get the performance of moving data from Hadoop to PDW or back from PDW to Hadoop as necessary. So that the parallelism is oftentimes, in my opinion, not emphasized enough when we talk about how cool Polybase is. All right, so let's talk about it a little bit and what we're doing there. So basically what we're doing is you have a query come into PDW. So you've created an external table over some sort of HDFS data. And what we're going to do is as a query comes into PDW, we're going to go out and query that data in HDFS and only bring back the columns necessary to satisfy the query. So you may have a bunch of, let's say, Twitter data sitting out in your Hadoop environment, and it may have 100 columns in it. But if you're only querying 4 of those columns, we're only bringing back those 4 columns back into PDW through those HDF blocks, through that parallel transfer. Bring it into PDW. We'll mash it up with the data in the join query that you may have in PDW and send back a result set. So that's really what it's doing when we talk about what Project Polybase looks like within PDW and how we're joining data. If you want to go the other direction, we can run a query within PDW and export that out to HDFS. Can anybody think of any good reason why you might want to do that? You have your data already in your relational environment. Why would you want to move it out into a Hadoop environment? What's that? For others to consume. That's a great example. So maybe you've done the first step, SQL in, results out. Maybe you had some of that Twitter data in Hadoop. You had your organizational data in PDW. You wanted to mash that up to get some new insights. So you bring it into PDW. You do some manipulations within PDW and some queries. You get an intermediate table. And now you want to push that back out into your Hadoop environment for others to consume. That is absolutely a perfect example of of how you can provide that out so now others can consume that data from Hadoop without having to come in and hit your PDW environment and compete for resources, for example. So if it's fairly static data that's going to be around for a while and lots of people are going to want access to it, and they don't need it very quick, they actually want to import it in their own environment or their own applications, that's a perfect example. Another example that wasn't really obvious to me at first, but the more I thought about it made sense, which is disaster recovery. Think about it from this aspect. You have a PDW appliance. You may have two PDW appliances, but you want to create some sort of disaster recovery scenario that's different than just doing a backup restore. A backup restore is fine, but what happens if your data center goes away and you don't have a PDW appliance to restore to? What do? So exporting your data out through Polybase into a Hadoop environment is a great way to just export all your data out for long-term storage somewhere else. You can then use some sort of SAN technology, if you're using SANs or what have you, to replicate that data out to another environment, and that can work out really well too. This also works with the Azure HDN site. So you can push this out into the cloud if you want to, for example, so that you have your backup of your data there. There's also, when you start thinking about it in those kind of terms, there's all sorts of examples of how you could probably deal with your data like that. So I talked a little bit about the parallel data transfers. Essentially what happens is, if you think about your HDFS data sitting out there in a bunch of text files, those text files within a Hadoop are broken down into blocks. And so when you see this kind of query here, with just two compute nodes, think of each one of those data nodes not only as just your HDN site blocks, but also or HDN site data nodes, but also think of them as the blocks within the data nodes. So each compute node is going to talk to a subset of those blocks out there in Hadoop and only bring the data back for that. And then we'll process it within PDW, move the data around, and join it up to the tables that you may have in PDW. And it's very efficient at that. And this is really just kind of the first step. Polybase v1, which is what's available now, is just really kind of the first step. We have great plans for Polybase with PDW to make it the place where you want to integrate your data between Hadoop and your relational data warehouse. The next step is going to be, as for the next version of PDW, we're going to be doing what we call pushing predicate pushdowns, which is basically pushing down MapReduce jobs from PDW into Hadoop so that we can get back smaller data sets and really kind of improve performance. So the idea is you can bring a SQL query in. We'll now send a map job to Hadoop so that it can run a MapReduce job within HDFS and bring back a subset of the data through the HDFS blocks and join it to our PDW data. That will significantly improve performance. It'll provide you much more agility and make this whole join of PDW and Hadoop even a closer process. And when we talk about PDW kind of vNext, when we talk about the next, what we call appliance update, which is kind of like a service pack, but since we apply everything to the appliance at once, we call it an appliance update. Appliance updates include all sorts of new features too. So it's like a service pack on drugs because we'll include all sorts of new features with each appliance update. Those come out fairly regularly. We're doing an appliance update basically on average about every 6 months. PDW v1 came out in 2009 or so, and it had 4 appliance updates, 3 appliance updates and a 3.5, which had some new features into it. V2 has been out for just a couple months now, and we're already looking at appliance update 1 by sometime before the end of the year. So when we start talking about these kind of features, it's really exciting that how quickly they come about, as the dev team is very aggressive in adding new features into PDW. All right, so the Hadoop integration kind of looks like this. You might have seen this morning. Creating an external table. Basically, you're just creating a table like you would in SQL Server, and then you're pointing it at your HDFS data in Hadoop with your location statement down there at the bottom. It's really straightforward. And that pretty much works against multiple Cloudera, Hortonworks, and HDN site versions of Hadoop. Looking at it from a slightly different format, you basically have an indicate with your external table, you give it the location of your Hadoop cluster, and then your file format, and you're done. And that basically creates a structure over your data in Hadoop, and you're off and running. Join, and from that point forward, that table looks like any other table to the end users, and they can join it to any table that you have within PDW and query the data as necessary. And PDW handles all that underneath the hood from then on out. So additional examples of how to go about creating the link tables. You can do it through, we have a new statement called a CE-TAS, which means creating an external table as select. So that means we basically can create an external table in your Hadoop environment, your HDFS environment, pulling data from PDW, or even joining the data from Hadoop and PDW and creating a new table within Hadoop with a CE-TAS, for example. So lots of options there to be able to do that stuff. And it's all done through the HDFS bridge, which resides on PDW. It's part of what we call the data movement service, which runs on each node within the appliance, which moves the data back and forth across the appliance. I'm not going to spend too much time on that. Basically, at the end of the day, you have a query against an external table executed in PDW. The HDF bridge reads the data blocks using Hadoop record readers interface. That data comes in to PDW. We then hash it on the distributed column if it's a distributed table, and we'll move it about as necessary to basically store the data for queries for the end users. So considerations that are kind of important. The data can be changed or removed at any time on Hadoop's side. You really don't have any control over that, really, from an end user. So if it's stored in Hadoop, if your Hadoop administrators want to delete that data, they can do that. When you say create external table, that's just metadata over that. The same thing in Hive is true too. So if you create a table in Hive, somebody can come out and delete the text files underneath it, and you can't stop them from doing that. PDW does not guarantee any form of concurrency control or isolation level, just like anything else in Hadoop levels, because we just don't have any of those guarantees. So the same query can get different results if that data has been changed and all that kind of stuff. Just caveats you have to understand when dealing with a Hadoop environment. It's the eventual consistency environment that we hear from the NoSQL crowd. And dealing with Hadoop, that's generally what you have to deal with. And here's some things on setting up and monitoring it. Not a lot of detail we really need to talk about today. So Power View integration. So this is actually pretty exciting to know that we have Power View. And how many people have users using Power View in their environments today? It's not that many yet, right? But we'll probably see a lot more of that over the rest of 2013 as people get Office 2013 is kind of important. And SharePoint as they continue to get the upgrades as necessary. But the ability to basically, when you start talking about terabytes and terabytes of data, and you start talking about Power View, you start thinking about tabular mode, and you think about in-memory, and it goes, how do you deal with all that in-memory technology and get Power View when you're over terabytes of data? Well, the way to do it is within PDW, we support direct query now. So what you can do is you can set up a Power View environment through a tabular mode and analysis services leveraging direct query against PDW to get some pretty good performance for Power View. So you can allow PDW to really kind of drive that Power View environment over terabytes or even petabytes of data if necessary. I try not to talk about the petabytes all that much because most people really are just getting into the terabytes range, and that's what we want to talk about. So Power View, along with our other tools, this is just kind of an eye chart of the kind of BI functionality and connectivity that we have to PDW and what drivers we have available, just to kind of let you know that Microsoft BI Stack integrates with PDW very well now. Just using the native drivers that we have available, you can connect to PDW and leverage whether or not it's analysis services in MOLAP or tabular mode, or it's reporting services or Power Pivot or what have you. We have the drivers for it to just leverage it as necessary. Also with SQL Server 2012 PDW, we've added a lot of T-SQL parity. So this has been a big driver for us from V1 with the RTM release through here, is to continue adding parity. If people had been on V1 talks and you knew the kind of data types that we supported and the lack of stored procedure support and the other things that we didn't have with the original V1, and you see where we are today in just 2.5 years, it's just amazing the improvements that the product group has made. And some of these are not trivial things to do, but basically being able to add the compatibility for things like SQL Server data tools. So to manage your PDW environment now, you can use SQL Server data tools, and so we have Visual Studio and data tools to manage our PDW environments. All our BI tools can connect to PDW, and then we have lots of third-party tools that can connect to V2 just fine. And here's just an example of some additional options that we have available that weren't available before. So things like set row count, DB ID, DB name. These are really important things that we need in our products so that the third-party products that are available that work with SQL Server can be more likely to be used against PDW. And that's one of the things that the product group has really been pushing for over time is to get that kind of parity. We're not quite there yet, but we're getting really close to having full parity between SQL Server and PDW. Lots of stored procedure improvements. And you can see here some additional set options that we have for stored procedures, the improvements that we've made, and additional system stored procedures that are now available within PDW. Some of these are not trivial in an MPP environment. So the fact that they've gotten these done over just the last couple of years has been pretty impressive. Additional metadata functions and security functions that we have available, like username and S-username, are pretty big. And then some additional catalog views and general T-SQL available. So lots of T-SQL compatibility there. So getting towards the end, we can talk a little bit about, in summary, we talked about any data, any size, anywhere. You can scale from a quarter rack. A quarter rack is just a few terabytes in size, and all the way up to 6 or 7 racks, and you start talking about petabytes in size. This is very compatible or comparable to what you would build if you were building a fairly large SMP box price-wise. If you start talking about a decent-sized DL980 or Dell's comparison, along with the SAN technology and then building out your SAN and all your disks, and so that you get the right I/O and trying to get your balanced I/O, you're probably right in that same kind of range as what you might be able to get with a quarter rack for PDW, and then be able to just know that you can scale out from there. Being able to do the visualizations through Power Views, important. And then finally, really important is virtualization, the management simplicity, the clustered column store additions are all really important additions to PDW. I have a few more slides that are screenshots, and I'll show them if there aren't any questions, but I'll take a few questions if you don't mind.
I know this is about change, but what does it take to get started? I mean, what kind of setup you need to do to your existing database to be able to put it into PDW?
So the question is, what do you need to do to your existing database to put it into PDW? The big one is what I started off with before, which is deciding what tables you're going to distribute and which ones you're going to replicate. So taking a look at your data warehouse and looking at it and determining, based on data sizes, generally speaking, what you're going to distribute and what you're going to replicate. And then once you decided that, the next thing is choosing a distribution column. So that's really important. So when you start talking about multiple fact tables, you want to look at which columns can be distributed so that you evenly distribute data across your appliance. So take an example of this. Let's say we have a fact sales table, and it's Microsoft's fact sales table. And so we have lots of dimensions in there, and one of them is product ID. And that probably wouldn't be a really good choice for our hashing because we sell lots of Windows and we sell lots of Office, but we sell comparatively less other items. Whether or not it's SQL Server, while we sell a lot of SQL Server, out in the environment, it's not in the millions and millions of installations like Windows 8 sold over 100 million installations in just 8 months. So and then we also have things like Dynamics and other things where you're really talking the hundreds or thousands of sales. So what you would have then is if you distribute it on product ID is you'd have one distribution with all your Microsoft Windows 8 professional sales. And you'd have another distribution with all your Mouse 3000 sales. And if you had enough products, then it might level out. But most likely in that particular example, it wouldn't because you have so many Windows and so many Office sales. What you're going to have is you're going to have some distributions with more data than others. And whenever you run a query against that table that includes that data, you can only go as fast as your slowest distribution. So ideally, we want to have level distributions and level data across the appliance. So you want to pick a different one. For somebody like Microsoft, in our fact sales table, customer would probably be fine. Customer ID is one of them that's going to be in there. Also, that is probably a good one because we'll probably have other fact tables that have customer ID in them also. And so when we join those two fact tables together that are both hashed on the same ID, we have no data movement because the data for both of those resides within the same distribution. And thus we're able to join them within the same data node without having to move data. Some customers are going to sell more than other customers, sure, but it's not going to have that wild distribution that we had with product ID. Plus, we have a lot more customers than we have products. And so we're going to be able to spread that data out. So looking at those things before you move to PDW ahead of time is really important. And then looking how you're going to load data, whether or not you're going to use SSIS, or if you're going to use the built-in tool, which we didn't talk about today, which is called DW Loader, which is essentially a just kind of like bulk load for PDW. You drop files onto your landing zone, you kick off a DW Loader, and it loads data into PDW fairly efficiently. If you already have an SSIS environment running your data warehouse, we have connectors for PDW for SSIS. So just dropping those into your current SSIS path and changing your destination adapters is actually a fairly reasonable way to go. And what that does is that actually, SSIS is actually pretty exciting when the way it loads data into PDW is, again, it loads it in parallel. So you have this one loading zone with SSIS running on it. When it connects to PDW, it then understands that it has 10 nodes or 20 nodes or however many compute nodes you have, and it starts loading data across the nodes in parallel. It doesn't go through there isn't a bottleneck of a control node as it loads data. It actually loads data to all the nodes at the same time. So it gets really great performance that way. Is there any way to test this technology? And the answer is yes. So we do have PDWs at all the Microsoft technology centers across the world. Also, our partners like HP and Dell also have some appliances available. And so basically what we do is there are POCs, proof of concepts, that the sales team will do with you, in which you will take a set of your data and take it into a Microsoft Technology Center and load it up and show you, the difference in performance based on a, defined set of, hey, if we do this, these are the things we're going to do, and try to scope it down into a 2 or 3 week POC. And I would just say, talk to your Microsoft sales representatives to kind of set that up. Yes, sir. Do we support multiple site failover? No, we do not yet. So PDW as an appliance, we don't use always on, there is no replication. We do have backup, so you can do backups to a backup server, and there's a reference architecture on how to build a backup server, and so we can do backups to it. Like I said before, if you had a Hadoop environment, doing remote table copies out to the Hadoop environment and doing something with that can be pretty exciting. What a lot of customers are doing today in V1 is, if they have multiple appliances, is doing dual loads into both. And sometimes they'll have maybe 3 racks in one data center, and then maybe only 1 rack in another. And they're just keeping a subset of that data in the second place. But we don't have anything like that yet, no. Yes, sir. So the question is, in case of one disk failure, what happens to the data on the disk? And the best way to see that is to go back to that picture that I had at the beginning. And what happens is, each disk within the JBOD is in a RAID 1 array. So what we have is, we have 32 distributions or 32 files across each node. So we have So what we have is I'm sorry, let me slow down. What we have is we have 16 files, and it's basically 2 files per file group for each distribution. And each one of those files is across a RAID 1 array. So what happens in a failure is, one of those disks fail, let's say disk 2 up there fails, and disk 1 has a copy of that data. When disk 2 fails, you'll see down there at the bottom that we have some extra disks that are not highlighted. One of those disks will kick in, and it will become the second disk for that RAID 1 array. And the data will be copied from disk 1 to disk 67, and then you'll have a RAID 1 array again. And you'll have a light on the appliance there in disk 2. So if you're doing a walkthrough of the data center, the light will be on to let you know to replace it. Also, within PDW, if we go down here, which is my extra set of disks or slides, we have things like this, which gives you the overall health of the appliance. So what would happen there, if it was SQL CMP01, that overall checkbox would turn red, and you can click on it, and it will dig down into it and show you why, for that particular node, it's red. And it'll actually tell you, hey, disk number 2 in this JBOD is actually failed and needs to be replaced.
How long would it take to do the process copy the data back?
So first of all, the appliance is still up and running. You still have the data on disk 1. And what it will do is it will do the copy. It takes a few minutes depending on how much data is on there, a few minutes to an hour or two to get the copy so that you're in place. But I can tell you, I've been working with dozens of customers over the last 3 years. We have lost no data within PDW to multiple disk failures. So the reality is that you're always going to have disk failures in an appliance like this. When you start talking about hundreds and hundreds of disks, and you think that each disk can average like a lifespan of 5 years, and you start doing the division of 5 years times 12 months, and how many disks are in the appliance, you're always going to have disks failing in an appliance, and it happens in your SANs today. And the idea is, as soon as those happen, what we have is we have escalated response times for PDW within support, and escalated response times from our hardware vendors to get that disk replaced that day so that we can continue going. But you have multiple spares within the appliance before that even happens. I'll ask you first and then you, sir. Okay. All right, so the question is, if I create a table as a replicated table and I decide, no, I actually want to change it to a distributed table, can I just do an alter table? And you cannot do an alter table, but we have this statement called create table as select. And essentially what that allows you to do is define the metadata and the definition of the table at the same time you do the create table. So basically you make a copy of the table with your new schema, and you're done. And you can just delete the old table, rename the new one, and you're off and running. It's the simplest thing to do. We really, within services, don't worry at first about which distribution we pick and worry about whether or not it's the wrong one, because it's so easy to do. Because let's say you have 10 terabytes of data in a one data rack appliance. And so that's really 64 distributions. You take that 10 terabytes and divide it by 64 to get whatever number that is. That's actually how many physical tables you have back there and about the size of data. So when you do a CTAS and you create a new distribution, that's actually 64 queries going on in the back end to redistribute that data and to put it in a different format. It happens very quickly. We do terabytes at a time, and it takes just a few minutes to redistribute it, a couple terabytes of data. Yeah, one more. The next steps? Okay. Was it this guy? Oh, the map reduce one, okay. Go ahead and ask your question. So in PDW v1 or PDW v2 release 1, we're not doing map reduce jobs. We're essentially bringing all the data from the HDFS table or the HDFS that you're pointing at to bring it in. And when I say all the data, that's not quite true. Only the columns you specify, but we're bringing all the data in. So there is, if you have a predicate to say, bring me bring me these 3 columns from this data set where such and such happens. Well, we don't do that where such and such until it's into PDW. With the next step, what we'll do is we'll run a map reduce job to actually reduce that predicate down within Hadoop before we bring it into PDW to improve performance. So, yeah, so that will be in appliance update 1. Yes, sir.
Does the new column store add any restrictions or complexity with the indexing jobs?
Does the new column store add any restrictions or complexity with re-indexing jobs? No, so you can do a reorganize or a rebuild.
Okay, that's all online and all that stuff.
So yes, the question is it online? The alter index for a rebuild for a clustered column store index is online, yes. Also, whenever those tuple movers happen in the background, if it's automatically redone, if it's got enough data, that is also online. So that's really important for us to be able to provide those online operations to make it so that you can continually add the data as necessary.
Trying to kind of get an idea of the use case for this, because some of the other database appliance vendors position their appliance as a database consolidation device or server. You can have multiple databases moving to a database appliance. Does
So the question is, does PDW support the use case of multiple databases to an appliance?
Yeah, like consolidation.
Consolidation. Absolutely. In fact, we've had several customers that I've worked with specifically where basically one group wanted PDW for a particular project and maybe they had a couple terabytes of data, but it wasn't really enough to justify the purchase of an appliance. So what they did was then they went out and they evangelized within the company to find other groups that had data warehouses that they wanted to consolidate also. And really from an organizational standpoint, that's just a no-brainer. And they were able to do that, and that worked really well. I'll take one more question.
Suppose you have data distributed by account ID and you are running search ad campaign. And later you realize that your data is becoming too big or it's not even distributed. You want to do by campaign ID. Can you do a redistribution of data?
You can always do a redistribution of data by using CTAS. So create table select. You're going to create a copy of your data, so you're going to need enough space to be able to do that. But as long as you have enough space that's slightly greater than the table that you're redistributing, you can always redistribute on a different ID. All right, so I'm out of time. I really appreciate everybody staying until the end of the day. Thank you very much. You. Congratulations.
Thank you so much. Thank you.
Great questions.